communities. And in these professional learning communities, we're working on various things. For example, pretty much from like December to March, we were working on something called scopes and sequences, which is basically we would go through the entire curriculum of a core class that we were teaching. For me, it was Algebra 2. I would have to go through every aspect, every standard, every week in the school year, and we would map out meticulously what standard was being covered and what activities can be done in order to cover said standard. And we did that for part on like 3 months or so. I don't know. Then we're working on lesson planning and differentiated instruction, meaning that we were to go above and beyond our regular lesson planning and come up with differentiated activities that we could utilize. Now, the fun part is this: in order to institute any form of differentiated activity, you are going to have to move kids about the room. And if you're going to be doing that, then you're going to be assigning various kids online different things. So I have kids online, kids in the classroom, kids I can't see, kids that I can't move around the room into groups, yet somehow I'm supposed to be instituting differentiated instruction.
Yeah, you should just like tell them no.
Yeah.
Simply just say no.
We can't.
They say,
well, we can, but we can't.
To make differentiated instruction, you're like, no, cannot do that.
There are certain things that are expected of us in terms of our job. Now, the other thing is this: on top of all of these meetings, we still have to do regular lesson planning and grading for our regular classes. Yeah.
What about like teachers' workshops?
Those are the professional development days like we did on Monday.
Yeah, those are like,
and even with all that, you get paid less than garbage man.
Well, to be fair, do you want to be a garbage man?
No. If I'm getting paid.
I'll talk about that in a minute. It's actually an interesting conversation. Now, talking about Monday. Monday we have these professional learning groups that we're in. So I'm in like a group with like 15 other teachers in the building. We all meet on the computer via Google Meet or whatever. And each professional development day, it's something different. It was like brain-based activities or something like that on Monday, where they basically give us a bunch of like things that you could do within our classroom structure and ask questions and discuss things and things of that nature. It's kind of pointless, but at the same time, it's like I can be on mute and I can work on other things, which I typically do. Now, in terms of garbage men, like number one, it's like in one sense you might think like garbage man. In another sense, it's like, dude, they have to work all sorts of crazy hours. They have to deal with like the worst crap imaginable, the stuff that nobody wants that they're throwing out. They have to do all of this while being, marginalized by the rest of the community. Working all sorts of hours at like 4 and 5 in the morning. I'm just saying, it's a tough job.
Wake up really early for your district once a week.
No, not once a week, dude. Not once a week. They do a section of the town once a week. Anyway. But I'm just saying, like, in terms of being a teacher, like, I understand like they're talking about the pay, but here's the thing that you got to know about the pay. In certain districts, especially this district, what makes up for it is the health insurance. You know what I'm saying? And the time off that we have. We do have summers off. Yeah. I've had 2 kids. Yes, they do, and I do too. But my family's had 2 kids paid $0 to the hospital.
All right, you know what?
I'm just saying. And anything and everything's been covered. Anyway, did I post? Oh crap! I didn't post it. Crap. Sorry. Hold on. 1 second. Delete that. I posted the link into the wrong Google Classroom.
where's no one showing up?
Let's do this. Cryptology. Yeah, we were talking about garbage people for the longest time. They can go back and watch that. So cool. I just posted it. Now let's give them a couple minutes to catch up while I get what you guys going to be working on for the first part of this class period. But yeah, I mean, the health insurance is pretty solid. Not to mention like the benefits that I get, like beyond health insurance. Yes, I do get the summers off, but then I have the option to work somewhere else for that summer. Part of my pay is removed from every paycheck in order to account for summer pay. So like my regular paycheck is reduced by a certain amount and held temporarily, and then they give me those paychecks throughout the summer in order to help with budgeting. Not only on top of that, I am allowed as a school teacher to have not a 401k, but a 403b. A 403b is similar to a 401k. It's money taken out of your paycheck and put into a retirement account. But at the same time, they take it out of your paycheck untaxed, which is amazing. Yeah. Don't have to pay taxes on money that's taken out of my paycheck, put into a 403b for a nonprofit organization. Now, for the summer, I've worked on a lot of different jobs. My first part of my career, I've been working at a summer camp. It's actually where I met my wife. I met her in 2004 working at a summer camp. We're both counselors. And then, yeah, I worked there from 2000 to about 2013. Yeah. Maybe. No, I was a legend there. A legend. Yeah.
It was like
Yeah.
there was times like everyone meets in the gym and like we're just watching him like do Rubik's cubes. Pretty dope.
Anyway, so I forgot about I did that there. Yeah, we did like Wednesday classes or something like that. Yeah, you remember that. But
I was looking.
I got you.
Leo was hammering in that too.
Yeah, I know he's in my homeroom. Yeah, so. But anyway, so then the other thing that I would do is the past, well, not last year because of COVID, but for 5 straight years, I worked the 5 a.m. shift at Michael's Arts and Craft. I would work 5 a.m. to about 10:30, and then I'd have the rest of the day do whatever I want.
You're already up.
Yeah.
On normal schedules.
I could take my kids like places. Like I would get off work. One day we'd get off work, go home, have lunch, go to the Cape May Zoo. Yeah, and I worked my shift. And it was a fantastic job. They basically like the 5 a.m. shift. I was like stocking shelves, number one. But then number two, when there was nothing left to stock, they would basically be like, okay, here's the paperwork for building something. Go build it. Thanks. And they'd leave me alone for like 4 hours. And I'd be like, here, I finished it. Where do you want it? Okay, next set of paperwork. Thank you. I'll go build this now.
What are you building, like shelves or something?
Yeah, like you would tear down not tear down aisles. You would break down all the stuff on the merchandise on the shelves, take down all the shelves, clean the whole thing up, build it in a different configuration, stock up the new items that were coming in. Or if there was a freestanding object on wheels, I would have to build that thing from the ground up using nothing but zip ties.
The IKEA man.
Yeah, it was so fun. Yeah. And they paid me pretty well. They kept hiring me back for the summer, even though they weren't supposed to. Anyway, back to this. So a couple of reminders. Number one, Monday, brand new schedule. Going to have you for 84 minutes. We'll see.
An hour every class. Getting out of here a little.
We'll see. Anyway. Sorry, Sky just said, and these hybrid kids aren't caught up on the Markey lore. Shake my head. Didn't know about the summer camp. Anyway, I know. But anyway, so Monday, come back up, till 2:00. After this period is when you guys would have the whole lunch thing. And remember, on Monday, they're starting the one common lunch. Okay?
Yeah, that's like everyone has.
Yeah, it's going to be nuts. You'll see.
Everyone in the school has the same.
At the same time. Right here. I printed this out. I'll show this to the people online as well. But basically, after block 2, you can see block 2 down there. It goes to lunch, and the lunch is from 10:16 to 10:56, 40 minutes. Ah, gotcha. Well, basically, I don't know.
We'll find out.
We'll figure it out. Anyway, but yeah, we'll get that thing done. So, prime numbers. I have a paper that I want to read to you in part in regards to prime numbers that also talks about cryptology. I wrote this paper in college. In college, I had this class called the History of Math. And within the History of Math, we talked about, come on, you. We talked about any number of things, ton of different things. But one of the things we talked about were prime numbers. And what was interesting about it, if I could actually find that paper, there it is, cool. I'll load the thing up. A lot of people look at prime numbers as being worthless. And as we talked about last class period, prime numbers hold a very, very, very special place in my heart. But not only that, because of the advent of prime numbers, you are able to have secure data transmitted from one place to another. It's really fantastic. But the hunt for prime numbers has become a money-making venture. I've mentioned the Riemann hypothesis, but do you guys know something called the Great Internet Mersenne Prime Search? It's called the GIMPS project, Great Internet Mersenne Prime Search. Basically, it's this program that's been running for like 15 years. And you can download this program onto your own personal computer. And if you have like a gaming computer, a computer that you really want to test to see how like well it runs and things of that nature, you could actually use this program to do such a thing. But basically, it's this, you can volunteer to join it, and you download the program, and they assign you a certain exponent, and your computer then basically runs in the background to test to see whether or not that exponent produces a Mersenne prime, according to the formula that they have it in. Most of the time, you'll find nothing. But if you are one of the lucky few who actually have discovered a Mersenne prime, then you are entitled to a certain amount of prize money.
All right.
I've convinced you.
Yeah, absolutely.
But again, prime numbers, why are they needed? Why are they important? These Mersenne primes, mind you, they've only found like 55 of them in history.
How long have they been doing it?
Well, Mersenne primes have been known about for over 2,000 years. They've only found 55 of them.
Well, they only started doing them with computers, what, 20 years ago?
Yeah.
The latest,
For the most part.
give or take?
Yeah. Talking like 10 million digits.
Only 55.
Yeah, they've only found like 55 of them.
Brute force it, yeah.
I know, right? But my point being, though, it's big money for cryptology. So I wrote this paper. Now I'm going to, please forgive the grammatical structure of most of it, because I wrote this about 15 years ago. Yeah, I wrote, so please, there's also some typos, but let me read some of this to you. For mathematicians, prime numbers are the equivalent of elements for physicists. They are at the core of everything math. Any number can be broken down into a product of prime numbers, just like any molecule can be broken down into a list of elements. The key difference between the primes and the elements is in the mystery that surrounds the primes. The laws governing the elements are vital to any person drinking a glass of water or using a computer with a silicon chip. However, the primes have continued to bewilder anyone who has taken the time to study them. There are innumerable properties that have been discovered regarding prime numbers and some fascinating theorems that have yet to be proven. Up until the use of RSA cryptography, prime numbers have been considered by the average person to be useless. After all, they are but simple numbers that have no divisors except one and itself. How can they be of importance to the real world when so many other areas of math are plausibly used every day? Before RSA in 1977, was the mathematician who spent a career trying to tame prime numbers just wasting a life? Or was there something about these numbers that enticed the greatest minds in history to venture into the rabbit hole and enter Wonderland? The mathematician is not satisfied with a guess, a theorem, or an approximation. The mathematician is only satisfied with proof. Until proof regarding the whole of the prime numbers is determined, the mathematician will forever press on. Then I go into some of the history of math and the things that we've proven. But this is something that we're going to be doing today. In 200 BC, Eratosthenes developed an algorithm for finding prime numbers, known today as the Sieve of Eratosthenes. Prime numbers occur somewhat randomly compared to other number sequences. While the nth triangular numbers, the sum of numbers from 1 to n, and we talked about this the other day, and the nth square numbers, just n squared, no formula will map what the nth prime number will be. Quote, was this not another crisis to find that the primes did show a chaotic behavior appearing randomly distributed? Randomness, as described by Chaitin, could be not a problem to ancient Greeks. In fact, they made their gods play dice quite literally by throwing dice in their temples to see the wills of the gods. Prime numbers generally seem to reflect the real world in the eyes of our mathematical ancestors. After the Greeks, quote, there are then a long gap in history of the prime numbers during what is usually called the Dark Ages. This Dark Age in prime numbers would be broken until the 16th century, shortly after they take root in the forefront of the mathematician mind. Then we talk about Leonhard Euler and the Mersenne prime. Back in 1750, remember I told you those like 55 Mersenne primes? In 1750, they only had known 8 of them. I'll show you a list. I'll show you a list and actually the year that they were discovered too. Then they go into the details of what a Mersenne prime number is. Keeps going on and 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 on. Then it talks about some more theorems. I'm not going to waste your time with that. Carl Gauss, really interesting stuff. The Riemann hypothesis, something I talked about last class. David Hilbert and his 23 problems. I talked about that last class. There's a part that I want to get to. There it is. Cool. Why do we continue to chase this white whale of mathematics, known as the Riemann hypothesis, when no one even knows if it exists? Perhaps David Hilbert put it best when he said, "Wir müssen wissen, wir werden wissen," which translates to, we must know, we will know. Why would someone climb Mount Everest? Because it's there. It's one of the more interesting things about mathematics. We discover things because they're interesting to us. We don't care whether or not it has any practical application. But then, lo and behold, some computer programmers figured out how to use prime number theorems and basically inject them into cryptology. Insane. It's like, do you think the person studying prime numbers 500 years ago gave a crap? No. They didn't give a crap about RSA cryptography. They didn't even know what a computer was. Yet we're discovering things every day that eventually have practical application. It's really interesting. Kind of goes on and on and on and on and on from there. There it is. In 1977, arguably the most prominent practical use for prime numbers was published. 3 men, Ron Rivest, Adi Shamir, and Leonard Edelman from MIT, made use of Fermat's Little theorem in their construction of RSA cryptography. RSA is a computer algorithm for encryption that involves prime numbers and congruencies. Congruencies are the modular arithmetic that we've been doing. Using the theorem's property of prime numbers, the algorithm is virtually unbreakable in terms of computer security codes, and thus we have a practical use. I love it so much. I think I got an A- on this paper. Could have been better. There's a lot of grammatical stuff. Kind of goes on and on and on and on and on. You know, the funny thing is, yeah, I took a class called The History of Math. The funny thing is, I barely had to do any research about it because I've already read the books that had all these quotes in them. Oh, yeah, because it was in this book. It was in this book called by John Derbyshire about the Riemann hypothesis that I had read. Like at that point, I had probably read it like 3 times. Well, for me, it was a good book. Yeah. So, in terms of prime numbers, this is what I want to do at the beginning of this class. I want to work on the Sieve of Eratosthenes, and I want to walk you through what is expected of you. Now, for those of you in the classroom, you have a copy of this. For those of you that are on the computer, I'm about to give you or send you a copy of this with these numbers in there. The Sieve of Eratosthenes, if you think about what a sieve is, somebody with your computer, Google search for the definition of sieve, S-I-E-V-E. Google it. While I get this sieve upload or this paper uploaded for those online. Let's see what we got here. Who got it? No one?
Wait, how do you spell it?
Sieve. What'd you get?
A utensil consisting of a wire or plastic mesh held in a frame used for straining solids from liquids, for separating coarser from finer particles, or for reducing soft solids with football.
Okay. Is there any other definition on there? I mean, that one's pretty good, but
Put through a sieve is the very
Yeah, dumb down.
Yeah. You shut up.
there it is.
Yeah,
Sorry, I found the file that I wanted to upload. I just have to find the exact location of it now. Open file location. Right, that's where it was. Okay. Let's go here, here. Boom. And Sieve. Post. Let's Sieve if that works. So for those of you online, I just posted this, which you can print out. You can print out. You can open it in a Google Sheet if you want to. Which you actually, if you opened it up in the Google Sheet, it might be helpful because I'm going to be showing you how I'm going to cross stuff out in a little bit. Okay. So for you guys here, if you're using this Sieve of Eratosthenes, the way that it works is this. The definition of a prime number is a number that is only divisible by 1 and itself. Only by 1 and itself. 1 does not count as a prime number. It doesn't. Sucks to be it. Well, if a number were to be considered prime by a few different definitions, it would have to have exactly 2 divisors. Itself and 1. 1 only has 1 divisor. The other reason why you cannot have 1 as a prime number is because of what is known as the fundamental theorem of algebra. Give me a number, any number. Give me a 2-digit number that can be divided by something. 26, there we go. Here. 26 equals 2 times 13. Or more precisely, you could take 26 and you could break it down to 2 and 13. Fair? Now, the whole idea of this little tree of prime factorization is so that you can break a number down as far as it can go, correct? If 1 were considered a prime number, can you do that?
Yeah.
And then that, and then that, and then that, forever.
How long do you think Josh could do that before you realize that?
You got to give him more credit.
I give him 5 minutes.
So, Josh, he gave you would figure it out in 5 minutes, and you said it would take you longer. So, 1 does not count as a prime number. The first official prime number is 2. The first official prime number is 2. And I am going to put it in a little box like that. Now, yeah, we'll talk about 3 in a moment. But now here's the deal. Here's the deal. 2 is a prime number. I'm going to count over. Now, this is the way the sieve actually works, but obviously I'm going to show you a shortcut. But the way the sieve actually works is that, well, if 2 is the first prime number, every time we count over 2, 1, 2, we find a number that is divisible by that 2, correct? So 4 is not prime. Neither is 6 or 8 or 10 or 12 or 14. Now I set these rows up on purpose. You'll see why in a little bit. But basically, you could easily cross out all of the numbers that are divisible by 2. And as a result, remember now when I think the Sieve of Eratosthenes, I think people in a river sifting for gold back in the gold rush. If you think about the gold rush, and the people who did their job. They went down to the river. They had like this weird kind of like dish thing that had holes in the bottom. And they would pick up a bunch of dirt and they would sift it, hoping that if they sifted it enough, the water and the small particles of dirt would fall through and that they could find gold. Basically, we're shaking this paper of numbers. And what's falling off of it first are all of these even numbers because, by definition, they are all divisible by 2 and thus are not prime. Now, after you have crossed them all out, ask yourself the question, what is the first number that survived? Well, we just used 2. 3 is the next number that survived. I believe I did say first, so I do apologize. I meant to say next. The next number that survived was 3. So now typically, we would count over by 3s and cross out any number that is divisible by 3. But you're going to see a little bit of a pattern pop up here. Now, obviously, if I start counting over by 3, immediately I get to what? What's the first one? Yeah, 6. Well, what's the problem with 6? It's already crossed out. So I'll count over 3 more, and I'll get 9. So I will cross out 9. So in reality, I don't actually have to count over by 3. I can count over by 6, because if I count over by 3, then every other one will already be crossed out, right? Well, what's 9 plus 6? 15. Cross it out. 15 plus 6. 21. Cross it out. Now, watch this. We're going to do a couple of rows, and I want you to see a pattern. We're going to do a couple of rows, and then I want you to see a pattern. 21 plus 6. 27. 27 plus 6. 33. 33 plus 6. 39. 39 plus 6. 45. 45 plus 6. 51. 51 plus 6.
Someone else do this. I'm getting confused.
We're just adding 6.
I'm dumb.
I can't do basic addition. Shut up.
57.
57. 57 plus 6.
63.
63. 63 plus 6.
Someone say it. Jake.
Nice.
I'm not gonna say it. Jake's gonna say it.
69. 69 plus 6.
I hate all of you.
69 plus 6. 75. Can you see a pattern?
No.
Yeah.
Yeah. Plus 6, guys.
No. Look how that's crossed out on my board right now.
You go down. It was called
The third one you crossed
Yeah. Or you could think of it like that. You could think of it like that, absolutely. Where he just said, it's like you go down, like watch this, from in each column, you skip 2, you cross it out. You skip, look at this one, skip 2, cross it out. Skip 2, cross it out. Skip 2, cross it out. Or it's a diagonal. There's another pattern that's emerging from this thing. So basically, you can go down, you can do it either way. You could finish the diagonal, or, and this is what I'm going to do, I'm going to go down in each column, and I'm literally just going to go, all right, 1, 2, cross out, 1, 2, cross out, skipping 2, and then crossing it out. And if I did this correctly, and be very careful with how you're doing it, you should be crossing out any number that is divisible by 3. Thus, they are not prime numbers. So, let's see. Cross them out, cross them out, cross them out, cross them out, cross them out. That's up to you. Cross them out, cross them out. This is how the sieve works. Every time you shake it, focusing on a different prime number, another slew of numbers go away. Because any number that you are crossing out is not prime, according to the way that this pattern is set up. Now, the pattern is going to change depending on how you line up your numbers. Notice I lined them up in rows of what?
14.
Yeah, I lined up in rows of 14. That was on purpose. That was on purpose. You will see what I mean in a little bit. There we go. I just crossed out all of the numbers that are divisible by 3. And yes, all of those wonderful diagonals showed up exactly the way that we thought they would. And like I said, I just crossed it out, went down each column, just kind of skipping 2 and knocking them all out. This is the search for prime numbers. This is the search for prime numbers. Now, obviously, you talked about brute force before. Yes, of course, you could brute force it, or you could take every number and then be like, okay, can I divide it by anything? But Eratosthenes devised a way where he could quickly find the first however many prime numbers just using a very simple method. What's the first number that's what's the next number that survived? 5. Put a little box around it. So now I'm going to do the same thing where I'm going to basically count over by 5 and cross them all out. Now here's the deal. What numbers are divisible by 5?
Numbers that end in 5 or 0.
Now we've already took care of all the ones ending in 0 because we took care of the ones all divided by 2, right? So we only have to find numbers that end in 5 and cross them out. That's all you have to do. For 5, that is. So I'm just literally going to go left to right on every row. And I'm just going to cross out anything that is divisible by 5. Now, the thing is, because I don't have to check the zeros, because we already took care of them, it's like 25, 35, 45 is already done, 55, 65, 75, 85, 95, 105 is already crossed out, 115, 125, 135, already done, 45, 55, 65, 75, 85, 95 is already gone, 205, 215, 225 is already gone, 235, 245, 255, 265, 275, 285, 295, 305. Nailed it. Now, obviously, there's not as much of a pattern there with the 5s because now some randomness is really going to pop up. But now here's what I've done for you. Do you know what gift I've given you? No. I wrote these numbers out in rows of what? 14 is divisible by what? And 7. Meaning, if you look at the column that starts with a 7, every single number in that column is also divisible by 7. Yeah. Josh, what I said was this. Remember how I told you we landed up in 14? So halfway through is 7. 14 is divisible by 7, right? Because of the way that these columns are set up, every single number within this column that I'm going down is divisible by 7 because of the way I set it up. Exactly. 7 is the next number that survived. And you can even see 49, 77, 91. Yeah, those were, we can kind of figure those out. But then this entire column is gone. After 7, what's the next number that survived? 11. Now, 11 is going to be a little bit dicier. 11 is going to be dicier because we actually do have to count over. But I'm going to tell you something special about this. You ready? What's 11 squared?
121.
Now, 121 clearly is not prime, right? Listen very carefully to my words. This has been mathematically proven. If you go under 121, anything less than 121 right now is prime. Anything that's not crossed out on this list under 121 is prime. Anything over is not guaranteed. Anything over it is not guaranteed. Now, we know 121 is not prime. So I'm actually going to have to do this. Check this out. Look at my calculator real quick. I know 121 is not prime. If I add 11, I get an even number. We've already done the even numbers, correct? So in reality, I got to do 121 plus 22. Because if I add 11, I get an even number. So I'm going to cross out 121. What about 143? Is it still there? 143 is not prime. Cross it out. Boom, it's 165. We already did 165 because it's ending in a 5, right?
Yeah.
187, is it there?
Yeah.
Cross it out. 209.
Yeah.
Cross it out. 231. Oh, we already crossed it out. 253. Where'd you go, 253?
Yeah.
There it is. Cross it out. 275, we already did. 297. We already did. 319, we're off the list. After 11, what's the next prime that has survived? 13 is a prime number. 13 squared. You know what 13 squared is? Type it in. 13 squared. You laughed enough before, you can laugh again. $13 squared.
169.
There you go.
Hey-o.
So 169, I'm going to do the same thing. I'm going to cross out 169. But again, if I add 13, I'm going to get if I add 13, I'm going to get an even number. So I'm going to have to add 26. 195 we already have. 221, is it there? Cross it out. 247.
Yeah.
Cross it out. 273. 299. Cross it out. And then we're off the list. 17 is the next number that survived. 17 squared is 289, right? Cross out 289. Yeah. Oh, yeah. Cross out 289, though. Now, if I tried going on from 289, we'd be off the list. Yeah, we'd be off the list. 19 squared is 361. Is 361 on our list? No. Do you know what that means? Every single number that you have not crossed out is prime. Every single one. This is the sieve of Eratosthenes. By just simply going through what? We went through what? 1, 2, 3, 4, 5, 6, 7 prime numbers. Just by going through 7 prime numbers and checking them against this algorithm known as the sieve of Eratosthenes, you have discovered the first 63 prime numbers. Every single one of these numbers that you're boxing off right now are prime. Now, the interesting thing about prime numbers, there's a lot of interesting things about prime numbers. A lot of interesting things about prime numbers. Look at the numbers 101 and 103. Let me zoom in on this. Do you see the numbers 101 and 103? They are known as twin primes. They are twin primes because there is only one number between them. It has been theorized that there are an infinite number of twin primes. We can't prove it. No, I know. You can't prove about twin primes, though. Do you know why? No, they're not nonsense. They may seem like nonsense, but they will have a practical application one day. They will have a practical application one day. Here's the thing about prime numbers. Within the first 14 numbers on my list, how many primes did you find? Within the first 14. You found 6. You found 6 out of 14. Somebody do a division for me. 6 divided by 14 is, give me the first 2 decimals. 0.42. 42% of the first row is prime, right? Okay, let's go to the first 2 rows. How many more primes did we get after the first 2 rows? 3 more primes. What's 9 divided by 28? 0.32. Now, I could keep going down with this. Actually, let me go through the first 1, 2, 3, 4, 5, 6, 7. What? Say again? 127 is prime. Yeah. Let me go through the first 100 numbers. Just up through the number 100. There's 1, 2. I'll do it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Within the first 100 numbers, there's only 25% of them are prime. Here's the thing you got to know about prime numbers. The farther you go into the infinite of numbers, and this is what you were just saying. You said there's an infinite number of numbers? Oh, look at me real quick. Or you can see this. You can see this look on my face. There are an infinite number of numbers, right? But if I check the first 14 numbers, 42% of them are prime. If I check the first 28 numbers, 32% of them are prime. If I check the first 100 numbers, 25% of them are prime. This number is going to keep shrinking and shrinking and shrinking and shrinking and shrinking. Meaning we're going to be finding less and less and less and less primes the farther we go out on the number line. It's been proven that primes are infinite. It's been proven that prime numbers are infinite. Yeah. Much smaller percent, the bigger, the farther you go on the number line. Yet somehow, there are an infinite number. It's been conjectured that there's an infinite number of what we call twin primes. Yet they keep thinning out. Yet we keep finding them.
Blame the number 1 and 3.
Yeah, right. Like, here's another twin prime right here. Here's another twin prime right here.
149.
I know, it's insane.
197. It seems to be a lot of 7s and 3. It's all the odd numbers.
Not all the odd numbers.
Mostly odd.
Yeah, except for 2. 2 is a prime number.
So 25 numbers are just numbers that have number that's not prime between them.
Yeah, just one number between them. Yeah, just like one even number between them. And that's it. It's insane. Mersenne primes, and I'll look up the list for Mersenne primes for you guys. It's insane to think about this. And again, this is what is needed for cryptology in today's computer age. Mersenne prime. Look at this junk right here. So, oh, I'm sorry. There's only 51 of them known. There's even less than I thought. I said 55. Yeah. The last one that was found was in 2018. Right. But if I go down to the list right here. Come on, little thing. Where's my list? There it is. The list of known prime numbers. You can see that the first 4 were found by ancient Greek mathematicians. And eventually the 8th one was found by one of my favorites, Leonhard Euler. But look at the gaps in between finding Mersenne primes. And then eventually, they discovered them a little bit out of order. You can see like when they were discovered. Well, this was the first institution of computers. They first started using computers to find prime numbers in 1952. And then, yeah, Raphael Robinson.
So on the right column is like what they use to solve.
Yes, exactly. And then eventually you can see IBM got in the game. But still, there's like they're finding them. And mind you, this column right here, look at this one column right here. This is the number of digits. How many digits it is, and the number is on the left right here. You see this whole dot, dot, dot? That dot, dot, dot implies that it's too big for that thing.
I honestly think putting 1 on there is kind of cheating because it's 1.
What do you mean?
It is itself. It is 1.
Well, no, 3 is the first Mersenne prime. But it's 1 digit long.
I mean, you could change the number from 1 and 50. So
It's
then
number
change the
1.
marking.
Yeah.
You could.
But anyway, if you keep going down, eventually they use like more and more advanced computers. But right here,
So we're in the 2 million now.
right here, you see that right there? That is the first recorded instance of the GIMPS program. I apologize, it's more than 15 years. It's actually been 25 years. The GIMPS program has been running for 25 years, and you can join it yourself. But all of these people who have helped to find Mersenne prime numbers, the next largest prime number, they get a cut of that prize money. And you can see right now, that's actually an unverified milestone right there. You'll see about that. So 51, 52, that kind of thing. But you can see right now, oh, and there's another one right there. Lowest unchecked milestone. They have to check and double check it to make sure the computer didn't mess up.
So they're in the 31 million.
Yeah, digits.
So, Mark, they think those are correct, but they just have to double check.
Correct. You see this guy, Curtis Cooper? University professor. He convinced the IT department to install the program on every computer on campus. And he gets credit for it.
I'm going to tell the IT to do it on every Chromebook. It's going to be no more effective than doing it on a computer from the 60s, but it'll work.
Yeah.
Maybe.
Great Internet Mersenne prime search.
Maybe. It's a lot of Chromebooks.
If you go to mersenne.org, you can download it on your personal computer at home and have this thing running in the background. Well, the GIMPS project will get credit first and foremost, but then you will get credit as the second name.
So the GIMPS project gives you money, not anyone else's debt.
Well, let me show you. Hold on. Let me show you. Current progress, get started. Why join? Why join? Tradition for the byproducts of the quest. People collect rare and beautiful items for the glory, for the money. There are a few who seek primes just for the money. There are prizes for the first 100 million digit prime and the first billion digit prime.
Wait, so
You have to reach that milestone.
Yeah, so it's not even a point. So have you run the program? Do you know?
I have in the past, yeah. They randomly assign you things to check. Yeah.
I'd just be like, all right, give me like 1 million to 2 million.
And I will tell you that it takes a computer roughly a month to check one number. It's basically like free lottery ticket.
Let's just have Josh guess it.
Actually, you know what? It's also a month of your computer, so
Yeah, I know.
computers are pretty, valuable. You know what? I have a computer that
Just have it running in the background.
I was gonna turn it into a server, but
Just saying.
server when you can get $2,500.
That's 250,000.
Just like 1 or 2 zeros.
Yeah. Oh, goodness gracious. Okay. Now, I wanted to show you this because this has been one of my passion projects since I was in college. The Mersenne Prime Search, RSA Cryptology, stuff like that. Like, I've seen people, like, I knew a guy in college who had a t-shirt that had the source code for RSA cryptology on his shirt. It was awesome because they had released it to the public. They released the source code of the cryptology to the public, and yet still it can't be broken. It's insane. That's how good it is. Yeah, and like I said, results are forever because, again, if I go back to this list right here, I know it's a Wikipedia list, but this is official. This is official. You can see this guy, look at this guy, Curtis Cooper. He's got 2 down here. He's got 2 up here. Like, insane. Here, I'll look up his name right here. Curtis Cooper. He's currently professor at the University of Central Missouri. Yeah, using software from the GIMPS project. They found it with a blah, 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 blah. I know, right? Oh, gosh, it's so funny. But anyway, enough of that.
Oh my gosh, when everyone turns in their computers for the summer, I'm going to steal them all and make them do math.
If you say so.
Months.
Now we're gonna run the program in the background.
So, you guys just, and I'll double check this right here. You guys wrapped up phase 1 of the Enigma project, correct?
Yes.
That was due 2 days ago. Today,
My answer correct?
I haven't checked them yet. I hadn't had time to. Today, I'm going to begin assigning you phase 2. Now, I'm not going to be assigning you all of these today. But these are a part of phase 2. There's not as many. There's 10 of them. Yes, but I have actually set up, whenever you see like the Google Chrome thing, that's a PDF file. With all the PDF files, those are the ones that I have prepped. A lot of these are unbelievably short. They're unbelievably short. Let me actually just show you the first couple, and then I'm going to be assigning it to you later. What are you doing? Okay. It's just, okay. Nice. So let me show you the first couple. And like I said, I am going to be assigning you these today, or begin assigning you these today. This is the art of secret writing. Now, the art of secret writing, that's a phrase I cannot pronounce. One of the recommended techniques involves randomly pairing letters of the alphabet and then substituting each letter in the original message. So what they do is they take all 26 letters, they arrange them on a matrix like this, a 2 by 13 matrix, or a 13 by 2 matrix, I should say, because yeah, anyway. No, sorry, 2 by 13. They go row by, what are you doing? They go by row by column. And they randomly place them within that grid. But then, whenever you have a phrase or a word, if the letter A pops up, you replace that A with a T, or if the letter T pops up, you replace that T with an A. It's an interesting form of secret writing, and it's like if nobody knew you were doing it, that's kind of rough. Like, there's no rhyme or reason or pattern to this kind of thing. Yeah, it's like very simple, very straightforward, but it's difficult for the person writing the code if they have to memorize that. Otherwise, they have to have a record of it, and the person receiving it has to have a record of it. So the key itself is rather difficult, although it is a pretty ingenious method. Yeah, I don't know why it is, but that one's pretty straightforward. And then basically you have to decipher this. It is? Oh, yeah. I gotcha. Then, Dancing Man Cipher. Now, what's really interesting about the Dancing Man Cipher is that a couple of you did something similar with your steganography project. It's really interesting. Yes, it literally is just like the flag one, except it's a dancing man. It's what? No, you have to decipher which one's which. Oh, yes, because of the guy with the flags. That was the scenario. Imagine that these are just like carvings on a rock. You know what I'm saying? It does. This one's upside down. Yeah. It looks pretty awesome. Yeah, it's here we go. The Dancing Man cipher is over 100 years old. It first appeared in Sherlock Holmes. The Adventures of the Dancing Men. These hieroglyphics have evidently a meaning. It is a purely arbitrary one. It may be impossible for us to solve it. If, on the other hand, it is systematic, I have no doubt that we shall get to the bottom of it. That's a quote from Sherlock Holmes in this book, The Adventure of the Dancing Men. Yeah, pretty solid. There's a rail fence in here. You guys have done rail fence in the past. That one's pretty straightforward. There is...
How is it one and two real fans?
What?
Like,
You'll see.
there was that one time.
I'm going to leave that one to you. I've already gone through that one, but I'm going to leave it to you. Then there's dots and pinpricks. We've done dots and pinpricks before. Now, this one's interesting. It's an algebraic cipher. That's one that we haven't done quite yet, but it is pretty straightforward, the way that the directions kind of outline it. And then there's a route cipher. Now, what I'm going to say about the route cipher is this. Number one, we've done route ciphers before. However, this one is slightly more complicated. This one you might spend the most amount of time on. Just giving you the heads up. I am going to be assigning you the first batch of phase 2. I'm not going to see you till Monday, but I am going to have them due on Tuesday. I'm going to give you a little extra time to get that done. So I'm going to see you on Monday, but I'm going to have this first batch of phase due on Tuesday, and we will be able to review that stuff. And then hopefully by Monday, I should have gone through your work for phase 1 so we can talk about that, because I know you guys asked me a couple of questions about the phase 1 enigmatic character. Yeah, we'll talk about that on Monday when the time is appropriate. So, yeah. One last little tiny thing. You guys remember when you did the turning grills for me? I counted those towards the 4th marking period. Because, number one, the due date for it was pretty late in the marking period. And I thought, you know what? Let's just throw it into the beginning of the 4th marking period. This will be good for, everyone did it, which is why you just got the comments and feedback on it. So just giving you a heads up on that. Woo! Anyway. Oh, Monday. We'll have you for 84 minutes. I'll be able to watch more YouTube. Well, no, the imitation game. That actually is one of the recommendations for this course. And once we have more time, that is definitely a possibility. Yeah. Anyway, I'm going to wrap up the live stream here. If you have not left a comment, please make sure that you do so. I'll leave it open for a few more minutes. I can see the 3 of you who have left comments so far. And the bell's going to ring in approximately 30 seconds. It will.
My favorite part of the imitation game is when he has an epiphany. He's like, he'll